Hello, everyone. Hello, hello. Nice to welcome you, Annie, from or Mathieu, from Nethermind. Really happy to start and to kick off that second workshop of the Pragma Hackathon. Yeah, this workshop, I think that's one of the most interesting as well of the first day. We had one before with on icon abstraction, but I think like for many of you who starting with Cairo 1, who starting with Darknet, I think this is the place to be, from zero to hero on Cairo, with any. So yeah, I will give you the word and maybe yeah, let's wait a bit like 2 minutes and then let's you just present yourself, who you are, and what are you talking about today.
Yeah, just sharing my screen to start. All right, you should have the slides coming up very soon. So I'm a software engineer at Nethermind. I've been working there for more than a year now. I started as an intern working on the internship program, and I started working on Starknet and Cairo related stuff. And I did not really leave the ecosystem ever since. I've been pretty committed to um, make Cairo a more beginner-friendly ecosystem, and that's why I'm giving this workshop on how to get started with Cairo. Um, so yeah, in this workshop, we're going to see a lot of things about Cairo, and it's going to be an interactive workshop. So I hope that you have read the workshop descriptions because there are some requirements that you need to install first, but I'll talk about them later. Um, so yeah, we can start anytime now. Just let me know when, if we need to wait a few minutes for more people to come, or how you want to proceed.
Yeah, maybe just before the kickoff of this hackathon of these workshops, um, maybe we have set it an amazing gather uh, workspace today, so where people will be able to join and talk directly with Annie and I. So I will share as well the link later once the first phase of the introduction of any started, and so anyone can join that gather workspace and can directly ask question and talk with us. So that's a quickly brief. So if anyone has well, like doubts of how it work and yeah, so we'll be helping and onboarding you on gather. So I think you can kick off now,
All
Mathieu,
right,
and
amazing.
here we go.
Okay, so what are we going to see in this workshop? We're going to have a 10 to 15 minutes introduction about Cairo 1. Why is Cairo 1 needed and why are we moving away from Cairo 0? Then we're going to have hands-on exercise. We're going to be using the Starklings resource, which is an interactive tutorial for Cairo. And during that phase, we'll all meet on Gather Town because it's easier if you have any questions, you can just move your character and directly ask me the questions. You can share your screen. I can help you debug stuff or help you with any trouble that you might have. And then we'll take 10 minutes to interact with the Starknet network and see how we can use the Voyager Block Explorer to interact with contracts. All right. So what do you need for the workshop? You need to have Rust installed on your computer. If it's not already done, it's best if you can install Rust right now uh, while I'll make the introduction. You also need to install Cairo, um, and there's an installation script available in the Cairo book for that. Um, in case you don't have, okay, I'm gonna send you some links. Edouard, can you send them to the Twitch chat so that people can install stuff if it's not already done?
Yes, of course.
Um, and so that's the first link. Second one.
Yes, of course. Or you can directly yourself as well send it in the group chat, but I'm happy as well to send it from
I
my
don't have
end.
the Twitch window open right now,
Okay,
so
no worries. I do that for you.
um, maybe I should open the Twitch if there are any questions. Actually, um, let me join.
Yeah, if there are any questions, I can also stop you and
Okay,
and do so.
amazing. So if you don't have these requirements installed yet, please do it while I continue the presentation so that we can get to step two very easily. Right. So there were quite a lot of problems with Cairo Zero when it came to Starknet, and the main one was that it was not possible to prove a transaction that did not go through. So let's say that imagine you're um, having an ERC20 contract and you want to make sure that when you transfer tokens from A to B, the the amount of tokens that A has in its wallet is higher than the amount he wants to send to B. Um, in that case, if it's not the case and he doesn't have enough tokens, then the transaction will fail. And in Cairo Zero, failed transactions cannot be proven because it's impossible mathematically to prove that something that is not true um, is true. In that way, um, when you compile Cairo code into the Cairo VM, and then the Cairo VM executes this code on the Cairo CPU, it gets transformed into mathematical constraints and into a polynomial. And it's impossible to prove that a polynomial respects these constraints if it doesn't. So that was a huge pain point for the Starknet network because failed transaction could not be included into blocks because it's impossible to include them in blocks as blocks could not be proven and sent and like the state update could not be proven on L1, verified on L1. And that opens a huge attack vector for DDoS attacks because people could just submit thousands and thousands of invalid transactions that the sequencer would try to execute but fail. Um, and the sequencer would never get rewarded for these transactions. What Cairo brings is a layer of security, of safety, and simplicity for developers. It's designed to ensure safety and prevent runtime errors in Starknet contracts because it has a huge, it has a very strong type system. So, for example, low-level operation like accessing array elements with pointers and stuff are no longer possible in Cairo 1 because the array type is wrapped with certain functions and you cannot interact directly with the memory anymore. So it's impossible to have segmentation faults, like equivalent to segmentation faults where you access out of bounds indexes of memory, and you cannot try to write twice to the same memory location. Because one thing that is important about Cairo is that once you have written once in memory, you cannot write something else in memory. The memory is what we call write once. Once a value has been assigned to a memory cell, you cannot change it. But all of this is almost abstracted completely to the developer now with Cairo 1 because its syntax is very inspired from Rust. Um, and there are a lot of abstractions made for the developers so that the language remains easy to use. So some of the features of Cairo 1 that did not exist in Cairo 0 are, for example, a unique keyword to declare variables, only with let, where previously in Cairo 0 you had like 3 different keywords and each one had a specific semantic and was used in like different contexts that were not always easy to differentiate. As I said, the memory is immutable. However, you can have now mutable variables because it's all abstracted and there's a layer of syntactic sugar applied on top of the low-level Cairo that allows you to mutate your variables at the language level. There's a collection of native integer types that have safety features such as integer overflow and underflow checks. The type system is much better now because we have enums and structs, so your code can be more organized. And one good thing that was imported from other RAM language like Rust are generics. So you can have generic types in your code, which makes it a lot easier when you want to work, like when you want to avoid duplicating your code, but still have your code be usable with different types. One thing that is strongly inspired from Rust, but the implementation is a bit different, is the trait and implementation system. We're going to see that in detail in the exercises. And one thing we need to keep in mind is that Cairo has an ownership system that is a bit similar to Rust, which means that each value has an owner, and you cannot always, um, s- um, like for example, you cannot use the same value twice in different functions under certain conditions. You have to make sure that the value is either can be copied or that the value is passed as a snapshot, what we call snapshot, and we'll get into more details with that. Right. So, what are we going to use to develop in Cairo in practice when we want to like build something and bring it to production? There are three main tools for now. First one is Cairo Test. It's the default test runner for the Cairo compiler. So it's natively integrated to the Cairo compiler. Second one is Scarb. Scarb is a package manager, a bit like Cargo, and you can use it to manage dependencies, to compile your projects, and build plugins around the Cairo ecosystem. And it also serves as an entry point for other tools like Protostar. So Protostar is a Foundry-inspired development framework that allows you to write your tests and write your deployment scripts um, in a more native way. So, for example, you'll be able to write your tests and test them against DevNet instance in Cairo. How exactly can you learn Cairo the right way? There are two main resources right now. The first one is the Cairo book, which is a tutorial style approach to teaching Cairo. And you can follow step by step everything that you need to understand the language from 0 to 100. And the second one is the StarkNet book, which is more focused on the StarkNet side, StarkNet as a network, and you're going to learn how the architecture is built, which component has which role, and everything there is to know about development tools and versions, StarkNet specificities and stuff. So let's move to the second part of the workshop with Starklings. You can follow the link here or just type Starklings-Kai1 on Google to find the link to Starklings. Um, and we should meet on GatherTown if you have any questions, or you can just ask your questions in the chat, and I'll be answering them. So before moving to Starklings, I just want to sync with everyone to make sure that if you have any trouble installing Cairo or installing Rust, please write a message in the chat, and we can meet on GatherTown as soon as it's ready to discuss that.
Thanks a lot for this introduction, Annie. And yeah, so I just shared the link on here on the chat, and this is the gather link. So feel free as well to join here, and we'll be seeing each other directly and gather. You don't need to create a new account. You just need to type one of your pseudo, and yeah, just join the link. And I guess you will be as well there. Any?
I'm going there right now.
Okay, awesome. Yeah, I can see you. Okay, I can see some of you as well. Matteo the goat is there. He will wait as well up. I can take the change as well to the up. Wait as well a few minutes for people to join. Okay, here we go. I can see many people joining. That's cool to see. Nice. Now we can see as well. Okay, that's cool. Up. Okay, nice. Nice, nice, nice. Many of you joining. You wait. Stay there. I will just see if the other people down there. Okay. No, everyone's here.
All
So
right, amazing.
nice, nice, amazing.
So I'll be sharing my screen on GatherTown so that you can follow along. So now if you like click on my character, you should be able to see my screen. And yeah, before starting with that, I just want to make sure that everyone has the installation figured out. I hope that everyone has Starklings installed. If you don't have it, raise your hand or just like talk to me, and we can figure out how to fix it. Okay, cool. So just confirmation, can you like see my screen on GatherTown? Is that fine? I'll take it as a yes. All right. Um, so here is my terminal and VS Code. And yeah, so Starklings is a collection of interactive exercises that you can interact with directly from your terminal and your editor. So how do you launch Starklings? The first thing is you're going to use this command, cargo run bin dash dash um, Starklings. We get it straight from documentation. Cargo run dash dash bin Starklings watch. Right, everything is written in the README, but just to make sure I'm doing it at the same time. Okay, so how exactly does Starklings watch? You don't have to like the tooling is just verifying that each file compiles, and the only thing you have to do is make sure that each exercise compiles. So for example, here I'm running the exercises in order. I'm starting with the one that is called intro one. And in this exercise, I have a small line here that says I am not done. Um, when I'm done with an exercise, I need to remove this line, save the file, and it's going to recompile it and check whether or not it's compiling this time. So here's a very basic Cairo program that does absolutely nothing. It's just a main function without any arguments or parameters or instruction. It's just an empty main function. And a valid Cairo program always has an entry point, which is a main function. So if we see now that my first exercise is passed, but the second one, which is called intro 2, is not compiling. So why is this exercise not compiling? Because as I said, every Cairo program must have at least, no, it must have one single main function. I see a message in the chat. 1 second. Okay, no, it's fine. So to make this program compile, I'm just going to write an empty main function. And now the Starklings binary is running the program again, and we're going to see that this time it's going to compile. And now it's running exercise 3. So in exercise 3, things get a bit more tough. We have two different functions. We have the main function, which is going to be the entry point to our program, and we can see that inside this function, I'm calling another function, which is called add, with two parameters, which are 3 and 5. So this file is not compiling. Why? I just have to look at the compiling errors. Wait, just have to reset my terminal. Yeah, okay. So I can see here that I have compiling errors, and these compiling errors are telling me that the b here argument was supposed to be declared along with the type. So the basic type in Cairo is the fell252 type. It's um, restricted um, integer type, not an integer type, but it's a type that can fit up to 252 bits, which is roughly the size of the prime used on the star curve, and that's used to make the transactions provable. I don't want to get into many details, but just know that this is the basic type used on StarkNet. The second error we have is that we expected to return nothing, but we returned a fell252 from our function. So here I'm just going to modify the function signature. If you're familiar with Rust, it's nothing new for you here because the it's very inspired from Rust and everything is very similar to Rust. So now that I removed all these errors, you can see that my exercise compiles and returns a value which is 8, which is the addition of 3 and 5. So now I can go to the next exercise, unless there are any questions. Are we to exit from Twitch? Yeah, if you're in the room and you can hear me fine, you can just leave the Twitch. All right, so let's get to exercise 4. What's happening in exercise 4? Um, so I have a main function once again. This main function is calling the function add, and there is apparently no error inside the add function. However, it's also calling the function sub, and the problem here is that I don't have any um, type that was assigned to my variables a and b. So what I can do is just assign them a type um, and make sure that this error here. Okay, there's one thing I need to also focus on is the fact that in Cairo you can return something with two different ways. So the function sub should return the subtraction of a and b, so it must return an element. I'm just going to modify the function signature like this. And to return something, I can either explicitly do it with a return keyword, or what I can do is just remove the last semicolon. And when I remove the last semicolon, it acts like an implicit return and returns this value from the function. So now what I have is I'm making the addition of 3 and 5, but not storing the result anywhere. And then I'm making the subtraction from 11 and 7, and I return this value, and that's the value returned by the main function. So here you can see that I'm returning 4, which is 11 minus 7. Um, is there any question now? Is everyone able to follow along? Or if you have any troubles installing Cairo, just reach out. Sometimes it can be a bit they can be a bit of trouble. But if it's fine, then let's just continue with the next exercise. Yeah.
Yeah, any someone here in the chat asking all what he needs to install as well to follow along. Maybe can you quickly maybe share the link
Yeah.
here in the chat so
There's only one thing you need to really follow along, which is oh wait, 1 second. You only need to install Stark links. That's the base requirement. But ideally, you have the whole Cairo and StarkNet environment installed on your computer, so that you can have language server completions, and it can directly show you where the errors are on your code before you compile, and it's make the development experience a lot easier. But if you just open the link I sent and follow the instructions in the README, you can follow along without any problem. Right, if there is no other question, let's continue. And the next exercise is the one in variables. So we're going to learn exactly how variables work in Cairo. All right, so in this first exercise, I have two problems here. It's that it says that an identifier is not found. Why? Because x was never declared before. So what I'm going to do is just declare the variable x. And to do that, I have one single keyword, which is the keyword let. Now that I do let x equals 5, I can print the value of x without any problem. And that's how you declare a variable in Cairo. Right, let's go to the next exercise, which is variables 2. And by the way, you can see here that when I'm running the exercise 1, it outputs the value of x here because I use the print method, which outputs the value of a variable at runtime. So second exercise, here I'm defining a variable, but I'm not assigning it to any value. And that's not something that you can do in Cairo. Every time you declare a variable, you have to assign it to a value. So let's say that here x is 10. I'm just going to save the file. It's going to compile. And when x is 10, this branch of the if statement is executed. And you can see that my code outputs x is 10. Right, next one, variables 3. And here I am assigning a specific type to a variable, but once again, I'm not assigning it to a value. So let's say that I want x to be of type felt252, and I assign it the value 3. That works perfectly, but what I can also do is say that x is of type u8 and assign it the value 3. And that's also a valid syntax. But here, x is no longer of type felt, but it's an unsigned integer of size 8. I could also use un16, un32, or even un256, and it would print the output, uh, the value of the variable, without any problem. Next exercise, here I'm trying to assign a new value to a previously defined variable. And I told you in the introduction that you could have mutable variables in Cairo. And how to do that, you have a specific keyword that you have to use, which is the keyword mute. When you use this, this keyword when declaring a variable, what you are telling explicitly is that this variable can, its value can be changed later in the code. And this is what happens here. It was initially defined with the value 3, and now it's defined with the, now its value is 5. But it's not the only way of um, changing the value assigned to an identifier. Another way is what's called shadowing, and shadowing is just redeclaring, redefining a variable with the same name as one that was previously defined in the code. So what's happening here actually is that I'm using the type literal syntax to say that number is a variable of type u8. And here, what I'm doing is I'm just assigning the value 3 to number. And by default, when you assign values like this to, to variables, the default type used is felt252. So what happens here is that number here is a u8, but here is a felt252. And that's actually shown here. When I put my mouse over number, I can see that the type assigned to it is u8, but this one is felt252. Next one, we have constants. Constants are values assigned to variables at compile time, and they cannot be changed at runtime. So for example, here, when I'm defining constants, I have to specify which type it is. So let's say that number is going to be, I don't know, u into 128, but small number is smaller than number, and it's going to be bound to a u8. So I can just define them like this, and this code compiles, and I can access my constants from everywhere in the code. Right? So we're done with the variables. Is there any question at this step? Is anyone having any trouble installing Starklings or Cairo or anything? All right, let's keep going then. Primitive types. So we have a lot of different types in Cairo 1. And in this first exercise, I'm going to be demonstrating how we can use the Boolean type. So here in this example, I'm defining that the variable is morning, its value is true, and its type is of type bool. Um, and the exercise complains because here I did not, um, this line is not a valid line because there's no identifier and there's no value associated to it. So I can just say that is evening is, for example, false. And my program will compile correctly, and it's not going to print good evening because I defined it as false. So the condition is never going to be executed. Another interesting thing about Cairo, and which is a bit special, is that we don't have a native type for strings, but we have something that is very close to it. It's called a short string. And a short string is just fell to 52, in which you use the ASCII representation of each character to build, of your string, so that you can fit 31 characters in one string because your maximum value of your variable must fit in 251 bits. So let's say that here I define the first initialize C. I'm checking whether C is an alphabetical value or not. Um, Then if it's not, I check if it's a numerical value or not. And if it's still not the case, I can just say that it's not alphabetic nor numeric. All right, so I'm just gonna show exactly how it works. Let's say that my your character is going to be a number. Let's say it's the number 3, but it's a short string. It's of type short string. Um, I still have an error in my program here, and it says that the ref argument must be uh, a variable. And here, actually, the problem is that I did not define. Oh, it's just that I made a spelling mistake. um, okay, so here, the one I was expecting was that the ref argument must be a mutable variable. So here, when it's passed to the function, I pass it as ref, and you're going to see this a bit later, but just know that when you pass a variable as a ref, you must use the mute keyword on it to say that it can be mutated. So that's how I can define the short string. Good exercise. Um, what's wrong here? I'm trying to print something that is called name and print something that is called age, but these variables are not defined. So what I can actually do is you see here that I define a variable called cat and something, this looks like a name, it's a short string, and that might be the cat's age. And this is what we call a tuple, and a tuple is just a specific type. Sorry, just so that there was a question, why was strings not included as a data type in Cairo? Um, it was not, um, I don't really know, but it's not a type that exists yet. Maybe they're going to bring it in the future, but in the meantime, we can probably route our own implementation of strings in Cairo, but it's just not there yet. So what I can do is do what we call tuple destructuration. So let's say that this is look, this is tuple. A tuple is a collection of types of values grouped into one. And what I'm going to do is I'm going to destructure that collection into multiple variables. And this is the right syntax to do it. So what I'm doing here is I'm saying that all variables inside the tuple cat are going to be destructured into two variables, one that is called name and the other one that is called age. And when I print them, I just have the right values here. And finally, the next exercise, primitive types 4. In this exercise, we're going to see how you can convert, sorry, not convert, but if if you try to, for example, add two U8s and the result of the operation does not fit into a U8, you're going to have an error at runtime. So it's very important to make sure that you're using the right data types when you're writing Cairo code. And let's start with the first thing we have to do. We have a function that is called sum big numbers, and we want to prevent that an overflow happens when summing big values. So one thing that we might think about when looking at this function is that, okay, we want to sum big numbers and we're using U8s, so it's probably not the best thing to do. So let's just say that this function is going to take the U128 type instead. Right, so I modify the function signature, but now I have a problem here because I was expecting U128 and what I got was U8, so I'm just gonna remove this suffix, and the compiler is automatically gonna infer the type that was required, and you can see that the error here is gone. So if I use the type literal like U8 here, it explicitly says to the compiler this value is of type U8. But when I don't specify anything at all, the compiler just finds it himself. So the next thing I have to do is a function that is convert to felt. How exactly can I do that? You can see here that I import two different traits, one that is called into and the other one that is called try into. What happens is that when I use the into method, I transform a smaller type into a type that is bigger. So I can convert a U8 to a felt 252 because 8 bits are always going to fit in 251 bits. But the opposite is not true. I cannot transform a felt 252 into a U8 because it doesn't fit. If I try to use the into method, I'm going to have an error saying that the trait into is not implemented for the type felt 252 to U8. So what I have to use is something else, which is called try into, which is going to check if the value can fit, and if it doesn't, it's going to just throw an error. Right. So now all my tests pass. I have 3 valid tests, and I can just go on to the next exercise. Just before going to the next exercise, we just finished a section on primitive types. I just want to make sure that there's no question now. Are there any questions? All right.
I have
Yeah.
a question.
Yeah, sure.
Why did you use the type U128 for the some big numbers? Because you still have that overflow, right?
Yeah, but like U100, 128 is sensibly bigger than U8. And what I was actually doing in my test is I was summing twice the value 255, which is the maximum value of a U8. So I know that my test, for example, let's say that I have an application, I know that there is a cap. For example, there's never going to be more than 255 users. And let's say that I want to, I don't know, double it or something, I'm just going to have to change the type. Because here, if I, like if, wait, 1 second. If I just add another line and I'm like some big numbers, and I use the maximum of a U128, it doesn't work yet. That's not okay. But let's say, yeah, that would be valid if I was having like a test that was trying to use the maximum value of 128. sorry, let me start again. Um, in that specific case, I know that every time I'm going to call the sum big numbers function, I'm going to call it with a value that is smaller than the maximum amount of U128. So that's the right type to use. But I could still say that, okay, my application actually, I don't like, I might overflow on 128 bits. And what I'm going to do is I'm going to change the type and use uint 256 instead, so that if I need to have more um, values, I can like still do it. Now, when I'm summing big numbers, the types expected here are no longer uint 128, but they are uint 256. But it was just for the example. All right, let's take 5 more minutes on the exercises. And I think what we should do is just take a look at StarkNet contracts directly, because I know that's what is interesting for most of you. So let's see how exactly StarkNet contracts are written. So here I have the example of a basic contract. This basic contract has no storage, nothing very interesting. It just has a single function that returns a string. And let's say that this contract is Joe's contract, and this function just returns Joe's. However, I have a problem with that file. It's that when I try to test it and I execute this test contract view, there's a problem saying that the entry point was not found. And why is the entry byte not found? Because this function here has no modifier regarding its state mutability and if it can be accessed from outside the contract or not. And actually, when you don't specify it explicitly, all functions are internal to the contract. What I'm doing here is I'm saying that, okay, this is a view function. It's not going to modify the state of the contract, but you can still access it from outside. And once I edit these attributes, you can see that the test passes, and I can go to the next exercise. So one important thing I still want to talk about is how the contract syntax is made. It's going to be a little bit more obvious with this one. And you can see that the syntax is a contract is a basic native Cairo module that was annotated with the contract attribute like this. And when I do this, I'm telling the compiler this is not just a regular module, this is a Cairo contract. And inside Cairo contract, I can have like specific types, and I can have a strict that is defining all the variables that are going to be stored on the blockchain. So in this exercise, the first thing I'm asked to do is add a contract owner storage variable with the type contract address. So let's do this. And what I'm doing here is I'm telling this contract can store a variable named contract owner, and I can, once it's stored, and I can write to storage, and it's going to stay on the blockchain forever. So now what I can do is in my constructor, I can write the owner of the contract on deployment. So what I'm doing is I'm calling the contract owner um, write function, and as parameter, I just give the one from the constructor. Now, when I'm going to deploy the contract, I'm going to write into my storage variable that the owner is the one that I passed as parameter. And the last thing I need to do is to read the contract owner from storage and return it from the get owner function. And it's very similar to the write method I use here. I have to use the read. So what this does is it reads the owner from the storage of the contract and it returns it. And I do not put a semicolon here because I want to return the value from the function. Here I'm testing the second contract. We can just take a look at the test case here. I'm defining an owner. I'm deploying the contract here. And as deployment call data, I'm just passing this value here, Jill, in the parameter array. And now when I'm trying to call get owner from the contract, it returns the right value because the storage variable was written to upon deployment. Okay, let's see one last thing about Cairo contracts. is the mapping type. Mapping is like if you're familiar with basic programming, you probably know what a mapping has. It's a like data structure, and each key has an associated value. So let's say that let's try to understand what's happening in this contract. The contract is named progress tracker. So I guess I have multiple people interacting with the contract, and I want to track the progress of each of one. Um, let's take a look at the test cases. So I have an owner here that I should be calling. That should be that should be set in the contract. So indeed, I have a contract owner storage variable here that is written when I'm deploying the contract. So what I need to do here is to assert that the one calling the function is actually the owner of the contract. So I'm going to assert that yeah, one thing I need to specify that to access the value of the color of the transaction sender, so the color of a function, um, not a transaction sender, but the color of a specific function, I have some specific syscall, what we call syscall, which is called get color address that returns the address of the color. So now I only need to write this line, assert that the caller is the owner of the contract. And if it's not the case, here's the error message that's going to be thrown. Okay, second instruction, I need to set the new progress for a user. But what exactly is a progress? From the definition of this function, we can understand that progress is, so the key would be a contract address, and the value associated would be of type U16. I can also understand it while reading the values, the parameters from here. So I'm going to define my legacy type, my progress mapping, sorry, as a legacy map between contract address and U16. Here, all I need to do is write contract owner, right? Sorry, not contract owner, progress, and I'm writing the value new progress to this storage variable. Here, I'm reading from the storage mapping. What I'm doing is called progress read, and I pass the user as the key. Oh yeah, I just forgot one thing here. When I'm writing progress write, I forgot to, like the write function, we can actually, when you have the language server installed, you can just click on it. And it's going to take you to the definition of the function. And here it expects a key and a value, and I forgot to call with a key. Here I can just set the progress of the user, passing it as the key. Okay. Let's take 10 minutes to see exactly how you can interact with the Starknet network.
As well, Henny, hey, someone here from the chat in Twitch asking, do you know when, if, how the syntax will change?
Yeah, it's actually like right now they just released the compiler v2 with the changes in syntax, but it's not that it's not that much of a big deal when you deal with very simple contracts. It's when you start to have a lot of composability and multiple contracts talking to each other that it gets a bit harder, but the basics remain approximately the same. I'm going to try to update this tutorial when Starknet 0.12 goes live, because for now you cannot deploy anything with a new syntax on the networks yet. You have to use the syntax I'm presenting now.
Perfect, thanks.
All right, so we're going to quickly see how I can very efficiently write a Starknet contract. So let me, how can I do that? I'm going to just share this screen. One second. I need to share a new screen. Okay, so now I'm sharing the entire screen, and you can see my terminal here. So I'm going to start a new project, which is going to be called Pragma Workshop. And I'm going to use what I talked to you about, which is the package manager, which is called Scarb. So with this simple command, Scarb new Pragma Workshop, I'm starting a new, I made a mistake, new Pragma with a G.
Yeah, maybe for those who are wondering if we are back on
This,
Twitch.
and I'm starting a new Scarb package. A Scarb package has a configuration file, which is called scarb.toml. And as I'm going to deploy something on StarkNet, I have to specify StarkNet as a dependency of this package. So I can say that I want StarkNet to be superior to 1.1.0. And I need to specify that the target of my build will be StarkNet contract, I believe. That's how it's written. And I'm just going to write a very quick contract in this lib file. So as we said, a contract is a module. I'm just going to define a contract called Pragma Workshop and annotate it with the contract attribute. Then inside this contract, I'm going to have a struct to hold storage variables, and I'm going to store a value inside this. I want, for example, the value to be 128, to be stored on 128 bits.
Any? Yeah,
Yeah,
sorry to stop you. I don't think we're able to see your screen right now.
on GatherTown.
On GatherTown, no, we are not able to see your screen anymore on GatherTown. So that's why I thought you were back on the on the presentation, but yeah.
What is the essence of switching back and forth? People are saying they can see it.
Okay, strange. It's me.
Yeah, let me just restart it then.
It's strange, yeah. Okay, you see
You
it?
have
Okay.
anything popping up now?
Okay, okay. No, I get it. Okay.
You got it?
Yeah, I got it. Thanks.
Okay, great. Can you actually, is it big enough? I think it's big enough, but I
Yeah,
think.
yeah, it's clear
Okay,
enough. Okay.
right. So I have this storage structure in which I'm going to store a value on the blockchain, and I'm going to like write two simple functions. One is going to be called getValue, and the other one is going to be called setValue. So the first one is going to be a function without any argument that's going to return a U128, and it's just going to read the value from storage. I need to make sure that I don't forget the modifier here, the attributes of visibility. This is going to be a view function. It's not going to alter the state of the contract. It's just going to return the value that is stored. And the second one will be an external function because it's going to change the state of the contract. It's going to be a function called setValue. It's going to take value as parameter, and the only thing it's going to do is it's going to write the value set as parameter to storage. Right. So this is a very basic contract. I'm just storing a value on the blockchain, and I'm giving two functions to read from the value and read the value and write the value. So I'm just going to compile it using scarb build, and it's automatically generating the file that I'm going to send to the network. So this big file here is the compilation output of my contract, in which I have a part of the ABI. Where can I see it? Here I have the ABI of my contract, and you can see that I have two functions. One is called setValue, the other one is called getValue, and it specifies everything there is to know about the types expected and the names of the variables. Right, now, how exactly am I going to deploy this contract? So I'm going to open my Cairo virtual environment in which I have the StarkNet CLI installed, and I'm just going to call StarkNet declare. Wait, oh. Right, so StarkNet declare is the command that you are going to use to declare a class on the Starknet network. So when you want to deploy a contract, first you have to declare the contract class. And once you have the contract class declared, you can deploy the contract instance with the class hash. Right, so I'm just going to put the directory, the path to my primary. Sorry, the path is here. So I'm just declaring the contract path, which is the sierra.json file that Scarb build outputs. You don't use Protostar or Scarb to deploy. I'm not sure we can deploy with Scarb already, but I'm just using the CLI when it's for very simple contracts. As here I don't have any like parameters or anything to declare. So yeah, I'm just going to be, oh yeah, right. Every step that I'm doing here is actually explained in the book, but I have to set these two environment variables before calling this Starknet declare here. It just tells the Starknet CLI which kind of wallet is going to be declaring the contract. Sorry. So once these variables are set, you can see here that my transaction was sent, and I have the transaction hash and the contract class hash that were generated. And I'm just going to wait for it to be mined on the network. And we can check the status on Voyager. So we just need to wait for it to be received. Yeah. I not used to it yet because I don't even know if Scarb or Protostar have already things to deploy Cairo 1. I know that Protostar used to have for Cairo 0 and I was using it, but I did not check in the last 2 weeks, so maybe there's something new. But as I was saying, when it's a very simple contract, I just use the CLI. It's already configured on my computer, so it's just as fast for me. But yeah, if there's another method, I'm glad to hear about it. If you want to like send me some docs, send some docs to the people in the workshop, that would be great. Right, let me refresh that. All right, so my transaction was received. It's currently waiting to be executed by the sequencer, and you can see here that the class hash of my contract. No, sorry, you can see here the class hash that I'm going to deploy my contract on. So if you're wondering what exactly a class hash is, the class is basically the specification of your contract, the functions, the definition, what exactly is going to happen when you run your contract, and the contract itself is like the instance of the class hash. So a class doesn't, it's the instance of the class. A class doesn't have any state. It doesn't has storage variables or anything. It doesn't have state, but a contract has a state. It's like a class in Java and an object. The object is the instantiation of the class. It's kind of the same with Cairo and Starknet, where a contract is the instance of a class. So it's going to take the time it takes, but I think we already are running out of time. But yeah, this is how you're going to be declaring and then deploying contracts. So let's say that my transaction here is mined. I'm just going to copy the class hash and call starknet deploy and pass the class hash as a parameter here. And what I'm telling is that to the Starknet network is that there exists a class with this hash on the network, and you're going to create a new instance of it. All right, so here is my transaction went through, but the first one was not accepted yet. But if they are executed in the right order, it's not going to cause any trouble, and they should be executed one after another. But about this contract and class distinction, let's say that you want to deploy an ERC20 token, and you're using the OpenZeppelin standard for that. You actually don't need to declare it because someone else has already done it. So if you want to deploy the ERC20 contract, uh, you're not going to need to declare the contract because someone has already declared the same class on the network. You're just going to deploy a new instance of the same class for your specific token.
Also, we are 1 hour in, but like we are free to go and to continue. We are not run by the time, so
Okay. Uh,
so I
well,
mean,
this yeah,
it's up to you. It's up to
I'm just
you.
waiting for things to be accepted on L2. But apart from that, let's take like 5 minutes to answer any questions you guys might have. If you have any problems, um, if you have any problems with installing the environment, I know that it's not super easy yet, especially with the VS Code extension and stuff. So if you have any troubles, I'll be super glad to help you. And yeah, feel free to ask any question related to Starknet or Cairo. How do you get a class hash of the deployed OpenZeppelin contract? Good question. Um, Maybe if you go into Voyager here, um, that's actually super interesting. That's a good question. So if you go into Voyager here and you go to classes, you have a full list of classes, but I do not know how exactly you recognize which one is the Open Zeppelin one and which one isn't. But at some point, it's probably going to be written in the Open Zeppelin docs. Uh, they're gonna like yeah, they're gonna like deploy maybe deploy a contract themselves and write the class hash in the documentation. Or you can just like um, get their contracts, build it yourself, and then try to declare it. And the declaration will fail because it was already declared. So for example, here, if I try to declare my contract one more time, it's gonna fail saying that class was already declared, and it's going to give me the hash of the class. So yeah, that's how it works. Is the expected usage of scarb to have a new scarb folder per contract we want to deploy? No, no absolutely not. The expected usage of scarb is to have one folder, like one scarb project per project, not per contract. So let's say I want to have two contracts in my project, contract one and contract two. I'm going to do, let me just comment that for a while. I'm going to, so if there's a very well-written section about that on the Cairo 1 book, but everything in a Cairo project must be attached to the lib.cairo file, which is the create root of the project. So here I'm going to say, I'm going to declare that contract 1 file and contract 2 files, and now I can make two different contracts here. Contract 1, let me annotate it with contract, and do the same for contract 2. Wait, and then I'm going to call scar build, and it's going to output, you can see here, contract 1 and contract 2. It's going to compile both of them and give me the sierra.json file that I can send to the sequencer. And that's actually why you want to use scarb, and not using scarb would be a nightmare. It's because if you're trying to use the base Cairo compiler, you cannot have multiple contracts in a single crate. Yeah. Um, I only saw that on Alexandria, and I think it's because they want to make the clear distinction. Like, for example, if you need to use data structures, you might not want to use the math packages. So they have like, because it's supposed to be a community library, they don't want you to import everything when you only need one single package. But I would be interested to see if other projects that have multiple scarb files. So my transaction was actually accepted on L2. Let's see where my contract is. That was the transaction hash. This one was accepted on L1 as well. you can see here that in the transaction details, I can see that I deployed a contract. So let's go to the contract page and let's try to read the contract. What's going inside the contract? Well, the value is set to 0 by default, so you can see that I didn't set any value. And let me just open another browser to send a transaction. Here I'm just going to write something to storage. I need to connect my wallet. I'm using Agent X. You're going to use testnet. And here I'm going to write, for example, a value 10 to my contract. Oh, sorry, I need to refresh the page because I changed networks. My wallet is connected to Voyager, and I'm going to interact with my contract just by clicking the transact button here, and it generates a transaction hash. And now I only need to wait for my transaction to be detected by the network and executed by the network, and the value I will be reading here will be updated to 10. All right, so that wraps up everything. I use Scarbill, but I only get a CR file. Yeah, so as you can see here in my scarb.toml file, I had to specify the starknet dependency and explicitly say that the target was a starknet-contract. If you have any more questions, feel free to ask. Otherwise, we can stop it here. And yeah, good luck with the hackathon. I hope I'm going to see a lot of great projects from you. And yeah.
Yeah. Thanks a lot, Penny. I think that was very, very clear and very, very helpful for everyone. So yeah, there's no question as well from Twitch, as like some people are still on Twitch and couldn't be able to join Gather. If not, no, I can see people saying thanks on Twitch. So that's cool. That this has been recorded, so it will be available as well on YouTube, and I'll share as well all the details of Any and how you can contact him if you still have questions to ask him about this workshop or about anything else. I'm sure like he will be of a great help as well. So thanks everyone, and yeah, good luck with the hacking. And yeah, it's going to be a long 2 weeks. Thank you everyone, and I wish you a great day.
Thanks. Good luck.
Good luck. Goodbye.
Bye.